As we have seen in the last lecture, the op-amp consists of various blocks, and since these blocks can be anything, there is no particular circuit that you need to remember for the complete op-amp, but we need to discuss the characteristics, which are a very important feature in the op-amps. So first we'll start with the offset voltage. I told you that some properties of these blocks which I'll be explaining now. And the output offset voltage represents the voltage actually when both are equal, both the inputs are equal. So when both are equal, actually what the standard equation that we have is A into V1 minus V2, right? So according to this, when both inputs are equal, the output should be ideally 0. But what happens is, practically it is not equal to 0 because some small potential difference exists between these two terminals. This small output voltage that exists when input is 0 is called output offset voltage. Now the input output offset voltage is nothing but, as I told you here, this small voltage difference exists here even when these two are equal. So to make this 0, some voltage has to be applied here, which is some standard value for a given op-amp. This voltage difference that has to be applied, V1 minus V2, to make output 0 is called the input offset voltage. Okay, next, similarly we also have input offset current, which, as you can see from the above definition, that nothing but the difference between the currents flowing in the two terminals. Okay, next is input bias current. Input bias current is nothing but the average of the currents flowing in the two terminals. Next, the next concept is gain. Now this is a very important factor in the op-amp, because the gain, we can have two types of gains: common mode gain and differential gain. First let me explain what is a common mode. As we have seen in the input this offset voltage, when V2 is equal to V1, when both it's something like this. When you apply the same voltage to both the terminals, okay, this concept is called common mode. When you apply the same voltage to both the terminals, it is called common mode. And even in the common mode, we are getting some amount of output V0, right? So this common mode gain is nothing but AC, and the common mode output is nothing but AC into VC, where VC represents common mode voltage. Similarly, there is a differential gain which represents the normal operation when V1 is not equal to V2. Okay, so this is the second term, which is the differential gain into the differential voltage, that is the difference between V1 and V2, and the total output is like the sum of these two. Okay, next, CMRR. CMRR is a very important parameter. Even we had this in our block diagram, if you remember. Now CMRR is nothing but the differential gain to the common mode gain. Ideally, can you guess how much the value is? Because we know ideally AC should be equal to how much? 0. So ideally CMRR should be equal to infinity, but practically this is not so, and a high value of CMRR represents common mode rejection ratio, which is high. So it represents a good amplifier. Okay, next, the output swing. The output swing of an operational amplifier is nothing but the maximum value of the output voltage, this value and this value. What is the limit up to which the operational amplifier can go? And this value is nothing but, it's called Vsat, saturation, and similarly this is minus Vsat. Okay, the Vsat value can go up to this value, which is nothing but our supply voltage, and the minus Vsat similarly can go to minus VCC. So this is the relation, maximum value up to which op-amp can go. After this value, if the input increases further, this thing becomes constant like this. Even here it becomes constant at this value if the input increases further. This is called saturation of the op-amp. We will be dealing with this output swing when we discuss comparators, because comparators is a very important application of this principle. Okay. Next concept is slew rate. Slew rate is nothing but it represents the change in output with the change in time. In other words, it represents the switching capacity of the op amp. As the time changes, how fast the output can change. And remember, this is the maximum value of this change. So slew rate is nothing but it represents the switching capacity of the response of an operational amplifier. So these are the few main characteristics of the operational amplifier, but apart from these also there are a few characteristics like power supply rejection ratio, offset adjustment range, input capacitance, etc., which we don't have to discuss as they are not so important. Before we end this topic, let's just see what are the ideal values of all these parameters, because we need to have a very brief idea about how they behave. So as you can see, the slew rate should be infinity when the op amp is ideal. Output swing is anyway VSAT. CMRR should be as high as possible, so it is also infinity. Next, the AC common mode gain should be 0, differential gain should be high, so it should be infinity. The bias current, in this case both should be equal in an ideal case, so it will be I, whatever is the input current, and here this should be 0. Similarly, this should be 0, and the offset will also be 0. Okay, and before we end this, let's also discuss the characteristics, the diagram of a characteristics of the op amp. So ideally you will have the characteristics like this. This will be VSAT and minus VSAT depending upon input. So if input is positive, it will be plus VSAT. Input is negative, this input, remember, it corresponds to the difference. It is not a single input, it is a difference between two inputs. So if the difference is positive, it is plus VSAT, difference is negative, it is minus VSAT, and this sharp change is there because the slew rate is infinity. So in a practical case, you can have it somewhat like this. This won't be a sharp change because slew rate is not infinite. From some value we'll have a change. Similar, this is also VI, V0, and this will be VSAT, and this will be minus VSAT. Okay, but the change is not sharp. It will be a gradual change from some value to some value. Okay, this we will discuss when we discuss the basic applications of operational amplifier circuits. Till then, see you.